Welcome back. Today we are going through lesson 4.1, which is about graphing quadratics from standard form. So the first thing we want to remember is what standard form is. Standard form is when a function is written in the form ax squared plus bx plus c. So that's where a, b, and c are coefficients of some sort. And we have a function that's a quadratic in standard form. When we have the graph of a quadratic, it makes a U-shaped curve. It's called a parabola. So it looks something like a U, and we call that a parabola. What we're going to do is start to kind of figure out what those parabolas look like. So you're going to take out a graphing calculator and graph the two functions that are listed here, and kind of see what they look like to answer the questions below. So the first graph that they're asking you to graph is x squared plus 3x minus 4. And when I graph that on my calculator, it looks like this red curve right here. And then the second one they're asking you to graph is 2x squared plus 5, which is this blue-shaped curve here. So we're going to use those to help us identify some key features. So I can sketch just kind of the general shape over here of the two functions. They look something like this on that graph, so we kind of have that general idea. So in both those functions, the a value, that coefficient in front of x squared, is greater than 0. It's a positive number. So that means that the parabola opens up, and it means that it has a minimum value. So this point down at the bottom, we call a minimum value. The end behavior for these curves, both ends are pointing upwards towards infinity. The domain of these functions is all real numbers, so from negative infinity to positive infinity. And the range depends on where that parabola is. So if we look at the first one, it's all the real numbers above this vertex point, which is at negative something. And in the upper one, it's all the positive numbers above whatever that vertex point is at. So we would say the range is y values that are greater than or equal to the minimum value. So the y value of that minimum point, or the vertex point. So the way we would write it is we would say it goes from whatever that y value point is up to infinity, because it's pointing upward, so it's going up forever. Next, we're going to look at these two functions on the right side in b. So we have negative x squared plus x minus 6. And we have negative 3x squared plus 8x minus 1. So I would encourage you to graph those on your graphing calculator. And let's look at what they look like. So here is what they look like when I graph them. We can see that first one, negative x squared plus x minus 6, is this guy, the blue guy down below. And the other one, negative 3x squared plus 8x minus 1, is this black graph here. So if I sketch those onto our curve here, they look something like this. Let's use those to help us answer these questions. So for these parabolas and these quadratic equations in standard form, the a value in front of x squared is less than 0. It's negative for both of them. So that means that the parabola is now opening downward. And that point that it reaches is at the top now. So they have maximum values. Since they're pointing downwards and have a maximum value, their end behavior is going downward in both directions. So it would be going to negative infinity. The domain does not change, though. Our x, or our input values, do not change. We can plug in any real number. But our range does change. So now, since they're pointing downward, their minimum point is going down. So the range is the y values, or sorry, their maximum point is at the top. So that's its maximum, and then it's going down below that. So it's the y values less than or equal to that maximum value. So now it would go from negative infinity, because it's going down forever, up to that y value point, whatever it might be for this equation. Other thing that we want to notice is that for all of these parabolas here, when we notice their y-intercepts, those y-intercepts are going to be when x is 0, of course. All y-intercepts are when x is 0. And in these equations, when I plug in 0 for x, the first term disappears, the second term disappears, and I'm left with just the constant at the end. So that c value is what tells me where the y-intercept is. Okay, now we are going to take some of that information and use it to help us graph some quadratic functions in standard form. So the first thing that we're going to do is we are going to graph this example function up here, 3x squared minus 12x plus 6. We're going to graph that in standard form by hand. So we're not going to use the calculator to do it this time. We are going to use all the things we just talked about. So here's where we're going to start. Step 1 is to determine what kind of parabola. So we want to get an idea of what the parabola is going to look like. So the first thing we're going to do is we're going to identify those coefficients. So in this case, the a coefficient is 3, whatever's in front of x squared. The b coefficient is negative 12. And the c coefficient is 6. And then, again, we're trying to get an idea of what the parabola is going to look like in the end. We're going to determine if it opens up or down based on that a value. So a is bigger than 0 here. That means that it is going to open. And because it opens up, that means the vertex is at the bottom, which is a minimum point. So that's step 1. Step 2 is to find our axis of symmetry. So the axis of symmetry is a line that divides the parabola into 2 equal parts. So it splits that U shape in half. So it would look something, depending on what it looks like. If our parabola looks like this, the axis of symmetry is this line that cuts the left and right half into 2 equal parts. To find that, we use the formula. Again, it's a vertical line, so it's going through x. So it would be an x equals line. And the formula to find it is the opposite of b divided by 2a. So for our example equation here, we're going to take the opposite of b and divide it by 2 times the a value. So that's going to give me positive 12 over 6, which means that my axis of symmetry is at x equals 2. So I know that the graph is now centered at 2. So what I'm going to do, and I would encourage you as you go to do the steps as we go. So coming down to the graph, I am going to draw that axis of symmetry at x equals 2. So we draw it as a dashed line because it's not part of the graph, but it helps us make our graph. Okay, step 3 is to find the vertex, which is that maximum or minimum point. So it is the turning point of the parabola. And in order to find that, we plug the x value from that axis of symmetry up above into our function. So here's what that looks like. We are going to take that x value and plug it in. So we're going to say f of 2. And again, that 2 is coming from that axis of symmetry. So when I plug that in, I get 3 times 2 squared minus 12 times 2 plus 6. So when I get that, I get 12 minus 24 plus 6. And that gives me a y value of negative 6. So that means that my vertex is at 2, negative 6. So again, I'm going to use my graph to start plotting things. So if I go over to 2 and go down to -6, I can put my vertex on the graph there. So the vertex is just that maximum or minimum point on the graph. The next step is going to be to find f of 0. Remember, f of 0 is that y-intercept. So once we have f of 0, we'll be able to find a couple more points on my graph. So when I plug in f of 0, remember that's always just the c value. And in our case, the c value is 6. So that means that our y-intercept is at 0, 6. So I'm going to come down here to my graph, go to 0, 6, and put my y-intercept. Now, as part of that step, I can also take that y-intercept and reflect it across the axis of symmetry to find a point on the other side of the parabola. So since the axis of symmetry cuts our parabola in half, whatever's happening on the left side is also happening on the right side. So I'm going to take that y-intercept that I just drew and I'm going to reflect it the same distance straight across that axis of symmetry to get another point. So that point is at 4, 6. So once I know that y-intercept, I reflect it over the axis of symmetry to find another point on the other side. And then we can find some other points to help us fill in the rest of that parabola if needed. So you can choose any values of x and substitute that in. I like to choose points that are kind of in between that vertex and your intercept. So in this case, I would maybe choose 1 to plug in. So I would maybe do f of 1. And when I plug in 1, I get out -3. So I can plot that on my graph here. Maybe about there. And again, I can reflect that over. So it could go right over to the other side. And I know that I would also have a point 3, -3. Once I have that, then I am able to make a nice shaped parabola from those 5 points that I graphed. So my parabola would look something like that. Okay, we're going to use those steps to practice graphing some on the next page. All right, let's start with number 1 here. So again, the first thing that's most helpful is to identify those a, b, and c values. So a is 1, b is -5, c is 7. So I know that this is going to be a parabola that opens up and has a minimum value. All right, we're going to use that information now to find my axis of symmetry. The formula for that is opposite of b over 2a. So in this case, that would be +5 divided by 2. And that just means that the axis of symmetry is at 2.5. So we're going to plot that over here. 2.5. All right, then we use that to find our vertex. So I'm going to plug in 2.5 into my original equation. So I do 2.5 squared minus 5 times 2.5, and then plus 7. When I do that, I get a y-coordinate of 0.75. So that means that my vertex is over at 2.5. Remember, it's always on that axis of symmetry, and up at 0.75. So somewhere around there. All right, now I'm going to find my y-intercept by plugging in 0. And again, remember that's just the c value, which is 7. So I can come over to the y-axis and put a point at 7. And then I'm going to reflect that across those points. So going 2.5 the other way is going to put it about there. All right, so then you can use this table to kind of help you. So again, I like to pick points that are kind of close to the vertex, maybe in between the vertex and that intercept. So maybe at 1. If I plug in 1, I get out a y value of 3. So if I go over to 1 to 3, and then reflect that 1.5 the other direction, I end up there. So now I have enough information to make that smooth parabola curve. And again, I just reflected that point. So the other point would be 4, 3. All right, and then lastly, they're asking us about the domain and range. Remember that domain is always negative infinity to positive infinity. And the range is going from that minimum value, which is 0.75, up to infinity. All right, let's try number 2 now. So for number 2, again, it helps to identify the coefficients. A is 3. This one, the B value is not there, so we say it's 0, and C is -4. Remember, the constant has to be the C value. So when I find my axis of symmetry, I do the opposite of B over 2 times A, and that's just going to be 0. So my axis of symmetry on this one is centered at 0. All right, let's plug that in to find out where my vertex would be. My vertex in this case means I'm plugging in 0 for x. That's going to give me the C value of -4. So my vertex is at 0, -4. And I know from the parabola, because the A value is 3, it's opening upwards, so I know that's going to be a minimum value. My y-intercept here, remember that's also when we plug in 0, so we already know that one, it's -4. So this one's a little trickier because my y-intercept is my vertex. So that is the only point I know right now, so I'm definitely going to need some more points around it to help me out. So I'm going to plug in -1, and when I plug in -1, I get out a -1. So I have a point at -1, -1. I can reflect that over and notice that there's a point at 1, -1 also. And then I can do that one more time. So maybe pick the point of 2. If I plug in 2, I get out a y value of 8. So I can plot that, and then I can also reflect that one across that axis of symmetry. So I still have my nice parabola shape that I can make with those 5 points. All right, the domain for this one, always -infinity to positive infinity. The range, since it's a minimum, is going to go from that minimum value, which in this case is -4, up to infinity. Okay, let's look at number 3 now. So for number 3, my A value is -3. My B value is 6. Whoops. And my C value in this one is not there. I have no constant on the end, so that means the C value is 0. So let's find that axis of symmetry. The opposite of B divided by 2 times A. That's going to give me an x value of 1. So I know that my axis of symmetry is here at 1. So for my vertex, I'm going to plug in 1 to my function. It's going to give me a y value of 3. So my vertex is at 1, 3. And then my y-intercept, I'm going to plug in 0 for x. So if I plug in 0 for x, I get out 0 because there is no constant value. So that means the y-intercept is here at 0, 0. I can reflect that across my axis of symmetry to +2. So again, we know this is 0, 0. We reflect it to the other side. We also get 2, 0. And then again, I can pick another point if I want, or we can just use those points to make our parabola. Now I know from the A value and from the picture here that vertex is a maximum. So my domain and range finally are -infinity to positive infinity for the domain. And my range, since this one's pointing downwards, it's going from -infinity up to that maximum value, which was 3. Okay, our final problem here. We have an A value of -2, a B value of 6, and a C value of 56. All right. This has a negative A value as well, so I know it's going to be a maximum. Let's find that axis of symmetry. So opposite of B over 2A, that is going to give me an x value of 3/2 or 1.5. So this is over at 1.5 here. When I plug in 1.5 for the x value, I get out a y value of 60.5. So over to 1.5 on that axis of symmetry, up to 60.5. So just above 60 there on that axis of symmetry. So there's my vertex. And then I'm going to find my y-intercept. So plugging in 0, getting out my constant, which in this case is 56. So I have a point 0, 56. And if I reflect that over to the other side, it would be at 3, 56. And then again, if I need another point, because those are pretty close together in the y direction, so I might pick another point like 5 or something to plug in to just get a little better idea of what's going on. When I plug in 5, I get out positive 36. So that helps me see a point that's a little bit further away. And again, I could reflect that to the other side. We know it's going to make that U shape. My domain on this one, -infinity to +infinity. And since it's a maximum point, my range is going to go from -infinity up to that max value, which was 60.5. All right, that is graphing quadratics in standard form. We'll see you next time.